All right, this video is to cover problem 14. It says the graph of the polynomial function is shown below. Part A, based on the appearance of the graph, what seems to be the real solution to the equation? So if we look at the graph, the real solution is where it hits the x-axis, so that would be -2. Then it says, Sean does not trust the accuracy of the graph. Prove to him algebraically that your answer is in fact a 0 of y equals f of x. Show work and justify in the form of a sentence with the correct theorem using Mathonese, so using the correct technical language. So in order to prove that something is a 0, we should be able to divide and get a remainder of 0. So this actually incorporates our remainder and factor theorems, okay? The remainder theorem simply says that if we evaluate a 0, like f of -2, that whatever, if we get 0, then -2 is in fact a 0, okay? So don't confuse the number 0 with the terminology 0 as an x-intercept. So let's go ahead and get started by taking our -2. This is how we're going to prove algebraically that it works. So we line up our coefficients, do the math. -4, 2, -4, 0. All right, so basically, just by doing that, we have proved it, okay? So it says justify in a sentence with the correct theorem using Mathonese. So what we can say is, based on the remainder theorem, evaluating f of c will equal 0 if c is a 0. Okay? So based on the, actually I should say factor theorem. Based on the factor theorem, evaluating f of c will equal 0 if c is a 0. The remainder theorem and factor theorem go hand in hand. The remainder theorem just allows you to find any, verify any remainder, while the factor theorem specifically applies the remainder theorem to determine if a given value is indeed a 0, which can then create a factor if needed, okay? So based on the factor theorem, evaluating f of c equals 0, if c yeah, it sounds kind of weird, but it's correct. Based on the factor theorem, evaluating f of c will equal 0 if c is a factor. That's what I should say. I kind of was using shorthand in my head. Will equal 0 if c is a 0. Since f of -2 equals 0, we have proved, algebraically that the graph is correct. So since it equals 0, we've proved algebraically that the graph is correct. All right, I've already worked out 15, so good luck on your test, guys.